Okay, so let's create two new variables. Let's create a variable Chinese result of type string, and let's create a variable pinyin result of type string. And now let's consider several cases. So switch num. We've seen something quite similar before. So case 0 to 10, do something. Case 11 to 19, inclusive, do something. Case 20 to 99, do something. And then let's have a default value, that if we're out of this range. So in that case, the default case is quite easy. It's just return nil. And for the return result, if we survive the switch, then I would like to return a pair, Chinese result, comma, pinyin result. Okay, great. So we have the general structure. And then we just have to work very carefully. Okay, so Chinese result equals to Chinese digits with pinyin at position number dot 0. Now we could have it make it a little bit more descriptive. If we click on Chinese digits with pinyin, we could have defined the following data type. So this will be a pair. And the same goes for this part over here. Again, maybe it would have been wiser to create a struct. And this has to be actually an array of pairs, excuse me. It's my little mistake. Array of pairs, yes. Okay, now we can go back down, and instead of using 0, I can use .Chinese. And really, in the past, I did use 0 and 1, and it's shorter, but it just confused me, and it took me a while to get it right because of that. Because 0 and 1 is not very descriptive. And now pinyin result equals to pinyin digits with pinyin num dot pinyin. And again, I'm going to implement this. Maybe we'll realize later that we could have simplified things. But let's take things one thing at a time. Okay, now I'm going to duplicate this for 11 to 19. And let's use some string interpolation. Same goes over here. And this is where, if I would have used enums, things might have been a little bit easier. Now we need the number 10 for the Chinese results right over here. And we need the Chinese word sh over here. So that's great. However, this will not work correctly. Because okay, one thing at a time. So now what we want is the digit, right? So instead of num, we should take num mod 10. Okay, so that will grab the digit. And finally, we need a number between 20 and 99. So I'm going to copy this over here and then make the necessary changes. So first of all, it would be easier for me if I had let digit equal to num modulo 10 and let 10th place equal to num divided by 10 integer division. Okay? And for the first value, let's just grab this whole expression and put it right before the 10 symbol. Okay, and I want to use digit now. So digit. No, I don't want to use that digit. So this is the first number. So we need the tenths place. So tenths. And over here we need digit. So let's give this a little bit thought. What do we have here? So we're starting out with the Chinese part, taking from the tenths. For instance, if we were to enter the number 73, then the digit would be 3 and the tenths would be 7. So that would give us 7 in Chinese right over here. And that's exactly what we want. And notice that the tenths place in this case can only be the numbers 2 to 9. Okay? Now let's move on to this part over here. This part will enter the digit, right? So that's number 3 in this case, and get the corresponding Chinese word, which is great. However, if we were to consider the number 70, then the digit would be 0. Actually, this is confusing. Let's flip the, it's better. The digit would be 0, and then we would get over here, this would give us ling, right? This ling is a 0 in Chinese. So instead I should use Chinese digits with pinyin empty 0, or maybe a better idea, because this is starting to get confusing, would be to use an if statement, just like we did in play number. Okay, but I chose this approach, and it's not clear that it's readable. But this is the approach I chose. Now let's take care of... So you see, in a sense, this problem is not too difficult, but things can get complicated. Okay, so now over here, let's replace num99 with tenths. And let's replace num99 over here with digit. And instead of Chinese digits with pinyin, I'm going to use this expression. So we'll get the empty string for 0. Okay. So really there feels like there might be some room for improvement. And now we have something. Whether or not it works or not, that's not entirely clear, but that's what we have our test for. Okay, that's what we have our test for. So let's go to our tests. So we have test Chinese. Let's run the test and see what happens. Oh, and it seems like we have a bug, so let's go back. Oh, the equal sign was touching this. Okay. Very small bug. Okay, great. So let's go back to our tests. Chinese tests. So go to this arrow over here on the left, click on that, and let's run the test. So it's building, that's good. Running the test, and it failed. Okay, very good. Let's see what failed. So this is very interesting. We have Ersha, and here Ersha with a space. Right, the expected value was with a space, and that's very reasonable. But here I don't have any spaces. Okay, so we're going to have a couple of iterations that are quite interesting. So let's go back and introduce spacing where necessary. Now notice that only the pinyin failed, not the Chinese. Okay, so that's a very good sign. So I'm going to go back. And we need to take care of the pinyin. And in the pinyin, we need some spacing. So space over here. and a space over here, and a space over here, right? No, I introduced a mistake, excuse me, a space for the pinion. Okay, so I introduced a space on this pinion row and this pinion row. And let's see if there's an improvement. And I still suspect that we'll have a minor issue here. That's what I suspect. So let's run this, run the test. It's very exciting. We failed again, but we failed much less. And look what happened. We're left with a trailing space in the 0 case, okay? So we have a number of options. The first option is very poor. I can just change this over here, right? Add a space right here. But I don't like that. What I'd like to do is just trim the space from our string, okay? Right, if I were to introduce a space over here, this is kind of cheating. And we could run this, and it'll pass, but it's kind of cheating. So I'm going to undo the space, and let's go back. But it's almost perfect now. And now right here we have Chinese result and Pinyin result. So I'm going to say Pinyin result equals to Pinyin result dot trim characters, and I'm going to trim the white spaces from the left and the right. And we didn't have any such issue with the Chinese letters. So really passing the test is a little bit non-trivial. Now maybe we don't care about the spaces, so we could put this within the test. Okay, but you have to admit, this is very exciting. So now I suspect that we'll pass the test without cheating, right? Here I kind of cheated, and the test succeeded. So now we can be confident that our function works, and it's also future-proof, right? Maybe in the future we'll try a different implementation, right? Maybe we feel that our current implementation isn't very clean or isn't very readable, and we might end up breaking our code in the future. That's one of the main reasons to use a unit test. Maybe we're perfect. We have perfect code, which is probably not true. But we realize, okay, we could do much better than this very long function that I implemented, but we might introduce a problem. Now, another great advantage of the unit test is I did not have to implement the whole user interface. And also writing the test beforehand really helped us think through the problem, okay? So definitely one improvement I would suggest is to create an enum with these values, ling, yi, r, san, etc. Because copying and pasting this every time is highly error prone. And yeah, this was actually a lot of work. And also maybe have an enum for this too. Okay, great. So we're making progress. So have an amazing day and see you next time.